All right, so we're going to go into properties of logarithms today. We're going to expand and condense logarithmic expressions, and the change of base formula you're going to like because you can solve any log problem that you guys have been doing without a calculator with the calculator. So you'll like that one. All right. So it says, you know that logarithmic functions with a base b is the inverse function of the exponential function with base b. Remember, if it was written in log form, you could write it in exponential, or if it was written in exponential form, you could write it in log form. They were inverses of each other. Okay? So here are the properties of logarithms, which is just like the properties of exponents. All right? So if I have log base b and I'm multiplying two numbers, I can expand it into two logs and add the two. Just keep the base the same, okay? So if it's log base 3 of 3 times 5, okay? I can say that's log base 3 of 3 plus log base 3 of 5. Okay, I can just split them up, okay? Or you go the other way. If I have two logs with the same base and I'm adding them, whatever those numbers are, I can multiply together and condense it down to a single log. So we can go both ways with those properties. Okay, quotient property, quotient means divide, right? So if I have a fraction with the same base, I can split that fraction up into two logs and subtract them. Just keep my base the same when I do that. And if you have a log of a number raised to a power, that n, that exponent, you can put out front of the log and multiply it by the log. Or if you have, again, go the other way. If I have a subtraction problem, I want to condense it to a single log, I turn it into a division problem. If I have a number times a log, I can move that number to the number's exponent there. So we can go both ways. So we're going to be expanding logarithmic expressions and condensing them. Okay? So this is a division problem, right? This fraction. So according to this quotient property, what can I do with those two numbers? Subtract them. Okay? So I can change this, all right, to log base 2 of 3 minus log base 2 of 7, according to our properties of logs and a quotient or division problem. A fraction is a division problem, right? Yeah. So according to my directions, it tells me what the log of base 2 of 3 is, and it tells me what the log base 2 of 7 is. So I can substitute 1.585 for this one, and I can substitute 2.807 for that one. So then you just get your calculator out and subtract those. Okay? So you got 1.585 minus 2.807. We get negative 1.222. Okay? So now here later today, I'll show you how to use your change of base formula. You can do that using your calculator. Okay? Questions? So since it was division, a single log, I expanded it to two separate logs, and then I could use the information from the directions to do that. Okay? Any questions? Does that make sense to you? All right, let's look at another one. Okay, well, 21, and what did they give me up here? 3 and 7. What can I do with 3 and 7 to get 21? Multiply, right? So I can think of this as log base 2 of 3 times 7. That makes sense? So 3 times 7 is 21. So then we learned just a slide before that if I have two numbers that I'm multiplying, I can split it up, expand it into a addition problem. Okay? Just keep my base the same. So it's log base 2 again. So I can write this as log base 2 of 3 plus log base 2 of 7. And then I can use those numbers they gave us from the first one. Instead of subtracting, I can say 1.585 plus 2.807. Okay, so if I go back to my calculator, if I hit second enter, it gives me the same problem I just typed in. All I gotta do is change that minus sign to what? Addition. So we get 4.392. Okay, so you can manipulate your logarithms so you can figure out that type of problem before you know what we're going to learn here in a few minutes, the change of base formula. When we learn to change the base formula, we can just put this in our calculator and we'll get that 4.392. Okay? But you're going to have some problems where you have to condense or expand some logarithms. All right? How can I represent 49 with 3 or 7? Yeah, 7 times 7, right? Or 7 squared. So let's do the 7 squared part. Okay? So, again, we just learned this power property. Here's our 7, and there's our 2. What can I do with that 2? Put it out front and multiply it. Okay? So that's what we're going to do. We're going to use that power property to do this one. So I'm going to write this as 2 times log base 2 of 7. So I just move this out front and multiply it. So then I know, according to the directions, it told us that log base 2 of 7, what was it, 2.807? Do I remember that right? Yeah, 2.807 was log base 2 of 7. So I just do that problem in my calculator then. 2 times 2.807 and get 5.614. All right, so they used all three properties to help you show those in those three examples, I guess. So you can take an exponent and put it out front of the log and just multiply it by the log. Okay? Again, we're going to learn this change of base formula. That's going to be your favorite log rule because you'll be able to do all this stuff you've been doing in your calculator. All right, now this says expand it. Okay, now we got variables. All right, according to division, I can split this up into two problems and do what? Subtract them. When I do natural log, I always put capital L so it doesn't look like N. So I just split it up into two. Okay? Now, what's 5x to the 7th mean? What's that 5 in front of the x to the 7th mean? Add, subtract, multiply, divide. Means to multiply. So I can split that up into two problems. natural log of 5 plus natural log of x to the 7th minus natural log of y. So this multiplication problem here, remember that's multiplication, I split up into 2 and made it an addition problem. Okay? When you expand, they don't want any exponents. So what can I do with that 7? According to our properties we just learned. I can move it out front, right? So my answer then of this being expanded is natural log of 5 plus 7 times natural log of x minus natural log of y. Okay? So you've just expanded it. Now, if there's anything there that you can actually do, you should probably do it. Okay? Since I have a natural log button, right down here, right, I could put in natural log of 5 and get that answer, 1.609. But I don't know what x or y is, so I can't do anything there. So that would be as far as I could expand it. So I just put that in my calculator, natural log of 5. Now, what is the base again for natural log? E, thank you. All right, so just remember, this means log base E. All right, so that might help you simplify if any e's popped up instead of x's and y's. I could simplify some more. Questions on that? So that's expanding. You make it into as many logs as possible. Here's another division problem, so I can rewrite it as what? Natural log of 5, then what? Instead of addition, I can do subtraction, right? Okay, but what's 12x mean? 12 times x. Now think about this. Since that whole thing's in the bottom, I need to think about it like that. So I got my natural log of 5 minus, then parentheses, natural log of 12 plus natural log of x. I can split that multiplication up into 2 logs by doing addition. So I change multiplication to addition. I change division to subtraction. Making sense so far? What's the problem, Ben?
Most of it. How is this one even like? You said, oh, it can be subtraction. Why?
Division I can turn in.
Wasn't the other one?
Right. So division we turn into subtraction when we expand. All right. And then multiplication we turn into addition when we're expanding it into a bigger problem. Okay. In a minute here we're going to go the other way. They're going to give you something like this and want you to condense it down to that. Okay. So I didn't have to put parentheses around this because that's up top. I put parentheses around this because this whole thing's in the bottom. Okay? So that's just telling me I was dividing by both of those. Okay, now, when I have a negative out front of parentheses, what do we end up usually doing here? Distributing it through, right? So this would be natural log of 5 minus natural log of 12 minus natural log of x. This negative makes that plus, then I can drop my parentheses. So I expanded that, and then those two I could actually do Since they're just numbers, I could put those in my calculator, right? We already did natural log of 5, 1.609. And then natural log of 12, ln 12, close it up, 2.485. And then this one I don't know, because I don't know what x is. Then I could put those two together if I wanted, right? Since those are numbers. So I'd probably do it this way. Natural log of 5. So I can do it. It should be the same. Oops. Natural log. Natural log of 12. Negative 8.75. 0.875, sorry. That's all I could do as far as simplifying. Okay, so that was a little tricky because we had a multiplication problem in our denominator. So we had to put it in parentheses and then distribute our negative sign. So that's expanding. Okay, I think that's it for this slide. Yeah. No, not yet. Now they want us to condense it. Okay? So whenever you see, when you're condensing, whenever you see a number out front, do that first and move it to the exponent. Okay, Nolan? So I would rewrite this as log of 9 plus log of 2 cubed minus log of 3. Okay? Well, what is 2 cubed? 8, right? I'm just doing one step at a time so you can see everything. So that's what we have. Okay? Addition, I can turn into what if I want to put them together? Multiplication. So I can go log of 9 times 8. Which is 72. All right. What can I do with the log of 72 minus the log of 3 when I put them together? Divide them. So then this would be log of 72 over 3, which is log of 24, I believe. Isn't that right? So we condensed those 3 logarithms into that single logarithm. We took the 3 out front, made it an exponent, and then we figured out what 2 to the third was. That's how we got the 8. And then the log of 9 plus the log of 8 is the log of 72 when I condense it. Multiply 9 times 8. And then 72 minus 3 we can turn into log of 72 divided by 3. So we're going the other way. All right? Addition, we turn into multiplication. Subtraction, we do division. Okay? All right, so this 3 here, again, I would move where? And make that 3 cubed. What is 3 cubed? 27. So that's where the 27 came from. Okay. What can I do with the 4 and the 27? Multiply. So what's that? 108. Did I do that right in my head? Someone check me? Thanks. And what can I do with that subtraction problem? Divide. What's 108 divided by 12? 7? 9. Okay? So does condensing make sense? So when we're going from a big one to a single one, we're changing addition to multiplication and subtraction to division. When we're going the other way, expanding, we're changing division to subtraction, addition to multiplication. That's not too bad, is it? Questions so far? Okay. All right, here's our change of base formula. This is going to be your favorite. It says logarithm with any base other than 10 or e can be written in terms of common or natural logs using change of base formula. This allows you to evaluate any logarithm using a calculator. So this change of base formula lets you use a calculator for everything. Okay? So if you look at this, all right, the big number here stays in the top. You can change this to whatever base you want. I always change it to this one, which is what base? What's a common log? What base is for common log? 10, yes. And that's the one here on your calculator, log. That's the base 10 one. If you want, though, you could use the ln one, the base e one. All right, I always use the common one, the base 10 one. Okay? So the big number stays in the top. The base stays in the basement. Why do I say that's the basement? Underneath. Isn't the basement underneath in your house? Right. So the base goes in the basement of your fraction. That's how you remember what number goes in the bottom there. Okay? So I always change my b to a 10, which is the common log. Okay? So if I had, log base 2 is 7, that was that 2.807 we did earlier, right? Using the change of base formula, I can say this is the log of 7 divided by the log of 2. All right? So I just hit log of 7 divided by log, oops, I forgot to do what? Close it up, right? Log of 7, close it up, divided by log of 2, close it up. If you don't close it up, it messes you up. There's that 2.807. See? That's where they got those answers were correct answers for log base 2 is 7. We always go to 3 decimal places when we do these. Okay? So, what do I punch in my calculator, Sophia? How was your birthday Saturday, Sophia? Good. I forgot to tell you happy birthday Friday. You guys tell her happy birthday? We had it on the calendar, but I forgot. Happy birthday to you. You guys, not very good. Dear Sophia, happy birthday to you. Okay, so what goes in the top, Sophia? 8. Log of 8. And what's in the bottom? The 3. Okay? So it's that easy. All right? So put in there log of 8, close it up. Log of 3, close it up. Oops, not a plus sign. Delete that. And we get 0.431 if we go to thousands. Okay? Change the base formula. Okay, so, you guys were doing this stuff last week with, you were supposed to do that on the quiz, right? And how did we do that? What made it easier for us? We said equals what? X, right? And then we rewrote it as what? 5 to the x is 25, and you guys would tell me x is 2, AJ.
Come on, Dodge.
You said that.
I
That's the right answer, so
Okay.
fed him an answer.
So, but you guys did all this without a calculator, remember? That was on the quiz. Well, now, from this change of base formula, we can go log 25 divided by log 5. And what are we gonna get? We're gonna get that 2.
I think he did the top one.
Oh, I did times. Thanks. See if you were paying attention, if you're awake on a Monday morning. I did this wrong. You guys see that? I forgot to hit divide, right? No, it's not. Okay.
He's doing what I do, man.
Log of 8. Yeah, don't get in a hurry like me and make careless mistakes, right? So I have to change that. It's 1.893. So this was wrong. 1.893. Thanks,
For the whole time.
Thank you.
Mr.
I
Wise.
thought I was wrong.
Okay. So
I don't know.
what's this answer? Yeah. Log of 24 over log of 6. The only mistake guys will make, or girls, is they'll flip it. Right? Make sure the base stays where?
The basement.
In the basement, right? So, we got this? Pretty easy stuff now, right? It's been pretty easy the whole time, hasn't it? Oops, hit log.
When can we start doing differentials?
When you get in calc.
Like years.
1.774.
We could go to
Like trains and stuff, like
There you go.
I had to see them now.
Good job today. Also, I'm giving you a extra practice worksheet. So this and the practice worksheet, extra practice, is due Thursday, because that's the next time I'll see you. All right? Any questions?
No.
All right. Good job. You'll be able to probably get the homework done